Okay, hello students. We'll start the preparation of alcohol in this video. So last class we stopped at preparation of alcohol from alkene. So we'll see how we prepare alcohol from alkene. So there are two methods of preparation of alcohol from alkene. You can prepare by direct hydration in presence of an acid. Now, hydration means addition of H2O, water molecule. So let us take an alkene, CH2 double bond CH2. The name of this alkene is XII. We'll add water, that is H2O, in presence of an acid. Preferably, you can use sulfuric acid. So, when you take alkene and add water, it's basically an addition reaction. Now, in water, you have a positive part and a negative part. The positive part is H positive, and the negative part is OH negative. So, in alkene, the pi bond will be removed and one of the carbon will get the positive part, whereas the other carbon will get the negative part. Say this carbon gets the positive part, so it will become CH3, single bond CH2OH. And the name of this compound is ethanol. So in case of symmetrical alkene, that is alkene with equal number of hydrogen atoms with the carbon forming double bond, the formation of alcohol is simple. But what if the alkene is unsymmetrical? Like CH3, CH double bond, CH2 plus H2O, addition of water in presence of acid. Now in case of an unsymmetrical alkene, it will follow Markovnikov rule. Now, what is Markovnikov rule? The negative part of the molecule to be added goes to the carbon atom having lesser number of hydrogen atoms. Now, these two carbons, they have double bond between them. This carbon has got one hydrogen. This carbon has two hydrogen atoms. So, the carbon having lesser number of hydrogen will get the negative part from H2O. So the negative part is OH. So OH will go to this carbon and H will go to the terminal carbon. So we'll get this product. CH3, CH, OH, CH3. So this is Markovnikov product. Name of this compound is propane 2O. Next, let us see another method from which we can prepare alcohol using alkene. The name of the method is hydroboration oxidation method. So in this process, the alkene is treated with boron in presence of hydrogen peroxide to give alcohol. Now, the reaction of boron and hydrogen peroxide with alkene gives the same product as we got in direct hydration method. But if we use unsymmetrical alkene, the product will be different. In case of unsymmetrical alkene, hydration will give Markovnikov product, whereas hydroboration oxidation will give anti-Markovnikov product. Let us see the reaction. So you have this alkene CH3, CH double bond, CH2, BDO6 in presence of hydrogen peroxide. Now here the negative part will be added to the carbon having more number of hydrogen atoms. So you have CH double bond CH2. So this carbon has more number of hydrogen. So this will get the negative part, that is OH. So we'll get this product, CH3, CH2, CH2, OH. And the name of this compound is propene 1-ol. This is propene. So from here, you'll basically get application type questions like convert propene to propane 2-ol, or say convert propene to propane 1-ol. Now in case if you're asked to convert propene to propane 2-ol, you'll use direct hydration method. But if you're asked to convert propene to propane 1-ol, you'll use hydroboration oxidation method. So you have to be very careful when you write the reaction. You have to check the name of the reactant and name of the product very carefully. After that, you choose the type of reaction which are going to follow for the conversion. Okay? Next, let us see the preparation of alcohol from carbonyl compound. It is our second method. So from carbonyl compound. Now, before we start the conversion, the preparation of alcohol from carbonyl compounds, let us try to know what is carbonyl compound. Now, carbonyl is CO, that is C double bond O. So, whichever compound contains this carbonyl group, that is CO group, is known as carbonyl compound. Now, in this reaction, that is preparation of alcohol from carbonyl compound, we are going to use aldehyde, ketone, and carboxylic acid. So aldehyde, you have this carbonyl group, C double bond O. Now we know carbon can form 4 bonds. Now here carbon has already formed 2 bonds. So carbon can form 2 more. Now if both the bonds are with hydrogen, or one with hydrogen and one with carbon, it will give aldehyde. In case if both the bonds are with carbon, it will give ketone. And one with hydrogen, one with OH, or carbon and OH will give carboxylic acid. So example, you have the C double bond O, CH3H. Now you can see this is the carbonyl group. On right hand side you have hydrogen, on left hand side you have alkyl group. So this is an aldehyde. If you have this compound CH3, C double bond O, CH3. Now you can see you have this carbonyl group. On both sides you have alkyl group. So this is a ketone. So you have H, C double bond O, OH. So you have a hydrogen on the left hand side, OH group on right hand side. So this is carboxylic acid. More examples like CH3, CH2, C double bond O, H. Now on right hand side you have hydrogen, on left hand side you have alkyl group. So this is an aldehyde. So remember, for aldehyde there will be a carbonyl group, and the carbonyl carbon will be either attached to 2 hydrogen atoms or 1 alkyl, 1 hydrogen. In ketone, the carbonyl carbon will be attached to 2 alkyl groups. In carboxylic acid, there should be OH. One OH, and on the other side we can have either hydrogen or alkyl group. Now, when it comes to the naming, aldehyde, alkane will remove E and will add Al. So it's written as alkanal. In case of ketone, alkane name, remove E, add O and E. So it's written as alkanol. Whereas for carboxylic acid, alkane, remove E, add oic acid. So it's named as alkanoic acid. Now when we convert carbonyl compounds to alcohol, this is basically a reduction reaction. That means carbonyl compounds will undergo reduction to form alcohol. So for this reaction we need reducing agent. Now there are different types of reducing agent like lithium aluminum hydride, sodium boron hydride, or you can use H2 in presence of PD. So there are different types of reducing agent. So we'll use this reducing agent based on the type of reaction. That means the reducing agents are suitable for a particular type of reaction. Now, say you have this carbonyl group, C double bond O, H, CH3. Say this is an aldehyde, and you need to form alcohol from here. So you can see there will be a cleavage, means breaking of CO bond. So the CO bond, the pi bond will break, and there will be a formation of OH. That's how we have OH here. So there will be a formation of OH bond and CH bond. So in case of carbonyl group forming alcohol, there will be CO bond breaking and OH bond formation. So let us take this aldehyde, CH3, CHO. Now you have two carbons, so the alkene name is ethane, ETHA and E. Since aldehyde is replaced by Al, ethanol. It's going to be a reduction reaction, so we'll use a reducing agent. So we can use sodium boron hydride for this reaction. So when we use sodium boron hydride, ethanol will give ethanol. That is CH3, CH2, OH. So you can see the aldehyde will form an alcohol with the same number of carbon atoms. So the name of this alcohol is ethanol. Let us take a ketone, that is CH3, C double bond O, CH3. The name of this ketone is propanol. You have 3 carbon atoms, 1, 2, 3, so it's propane, and since it's ketone, E is replaced by O and E, propanol. If it undergoes reduction, so we have to use a reducing agent. So if it undergoes reduction, the carbonyl group, that is CO, will become COH. You don't have to change the position of OH. So you have CO here at carbon 2, so the OH also will be present at the same carbon. So you'll get CH3, COH, CH3. So this carbon 1, 2, 3. So you'll need a hydrogen here. So the name of this alcohol is propan 2O. Now if we take a carboxylic acid, say CH3, C double bond O, OH. If it undergoes reduction, you have to use a strong reducing agent like lithium aluminum hydride. So you have two carbon. Name of this carboxylic acid is ETHA and E. Now since carboxylic acid, E is replaced by oic acid. So the name of this compound is ethanoic acid. So if it undergoes reduction, it will form an alcohol with the same number of carbon atoms. So you have two carbon atoms here, so will form an alcohol with two carbon atoms. So it's CH3, CH2, OH. The name of this compound is ethanol. So from this topic you will get questions like convert ethanol to ethanol, or convert propanol to propanol, or convert butane 2-on. Now butane 2-on, 2 is the position of carbonyl group. The carbonyl group is present at carbon 2. So convert butane 2-on to butane 2-on. Or say convert pentanoic acid to pentanol. So you mostly get conversion, like convert one compound to another compound, or you'll get complete the reaction. So it's very important you study the reactions very carefully. You need to know the reagents, okay? So you have to practice the reaction if you want to do well in the organic chemistry. So in the next video, we'll see the preparation of alcohol from Grignard reagent. Thank you.